Lecture number 6. We talk about open source best practices. I'm trying to share what I know about open source with you and and trying to demonstrate you how people studied that area and what exactly they suggested for us programmers so that we can be more effective in open source community, so that we can be more productive and we can earn more respect, more popularity, and then in the end, more money. This entire course is supposed to teach you how to make more money while being a programmer and participating in open source projects. It's all connected to money, so don't take it as an academic story about making pet projects on GitHub and then sharing them with your friends. It's not about that. This course is about making you productive and successful as a programmer in your career and helping you to present yourself better and to grow your soft skills and to utilize the power of open source for your projects. Today we're going to talk about integrating. We already had a lecture about making pull requests and then reviewing pull requests and then making bug reports and then talking in those bug reports. All of those lectures are very important. But today we talk about, let's call it continuous integration. Even though it is called continuous integration, it's not that simple anymore. It was continuous integration 10 years ago when people got excited about automatically putting all the pieces of their code together and looking at the result, and then from this result making the management and technical decisions. This is what happened when they found out the continuous integration concept. It didn't happen 10 years ago. It happened way earlier than that. We're not going to discuss that. We will discuss how now continuous integration, or in general integrating on GitHub, can help you attract more contributors to your project and to help you stay in control. Because as we discussed many times, open source is about managing the chaos. The people who will come to your projects, they will introduce chaos. They will bring contribution to your code. They will make changes to your code, very important and valuable changes. But at the same time, they will try to break what you created before. And your job is to, at the same time, accept their changes and reject the damage which is coming together with the changes. And continuous integration, or in general automated integrating, will help you stay in control. So how it works? Before we go into the slides, let's just briefly discuss what I mean by integrating. You put your files in the GitHub repository. You use Git. As long as you work in open source, then you do need to use Git, and this is the de facto standard right now. Long time ago it was Subversion, and now it's Git. I don't know what's going to happen in the next 5 or 10 years. Maybe it's going to be a different system, but right now we all use Git, and GitHub is the primary place where we keep the code. Your code is just a collection of files, and I assume most of them are text files, because this is what Git storage is for. You don't keep their binary files, you don't keep their images, you don't keep your PDF files. You only keep the sources, the text files, which are editable by a human being. And then this collection of files is not yet a product, is not yet even a repository which you can claim to be a repository with a product or with the code. It's just a collection of files. You need to show me as a potential contributor or a user of your repository that this collection of files is not a random storage of something which you created because you had some free time, but this is actually something that together constitute a solid something. A product, a mobile app, a web service, or maybe some command line script or a set of scripts, but something which together is as a whole is a product. And how do you demonstrate it to me? And you have to. You have to demonstrate that. You have to show me that this is what I just said. And if you don't do that, then my suspicion is very high. I get very suspicious that that's just a mess of files. And until you prove the opposite, I believe that it is not a product, especially if you don't have many stars and many forks there. Of course, if you have 1,000 stars, then I do believe you. I don't really need to check whether there is an integrating system there in place or there is nothing. But until you get to that point, and most of you are not there yet, that's why you're listening to this course, until you get to the point where you have 1,000 stars, you need to prove to your users that you are not a stranger, that you are somebody who we can trust. And I said in the previous lectures that most people and most open source repositories, they are not trustable. They don't deserve our time. They're just garbage. The majority of repositories, they're just garbage. And only some of them are worth paying attention to. And that's why GitHub is sorting repositories, creating these trending lists, creating these catalogs where you can find something which is worth paying attention to. Because the majority of the stuff is garbage. So you don't want to be seen as garbage. You want to be seen as something which is interesting. And showing me that your code is possible to be put together, is possible to be compiled together, is possible to build into something workable, that's important ingredient of your success. Continuous integration originally was not for that. Continuous integration was originally for, I believe, for punishing programmers for making mistakes. That's what I understand the original intent of continuous integration was. They were just not happy that people break the code that was written yesterday. And they decided that it's important to find out who did that and somehow encourage them to not to do that again, or put it simply, to punish them so they don't do it again. So they introduced continuous integration, which is every day continuously, every day we build everything together and we raise a flag if something goes wrong. And we do it again after the next commit. And then we do it again the next day. So we continuously, non-stop, rebuild the whole system and find out what's wrong there. But then the open source showed up. And that got more interesting because there is not so many people to punish anymore, but there are way more people who are looking at that. So it's not only about you now, it's not only about your team, who definitely will benefit from continuous integration if you have that, because the team will enjoy this continuous check of their contribution. But it's very important for outsiders, for people who are not in your team, but they're watching you, they're looking at you. They're interested to know whether you are the team who they want to join with the commit, with the pull request. So you show them that we continuously put pieces together. We continuously integrate. You need to show me that you integrate. That's the final point. That's what I'm trying to say. You as a developer, you as a member of the team, show me, a stranger, that you care about making your set of files into a buildable something. So, as usual, I give you a number of recommendations which you can use in your open source programming practices. Recommendation number 1, you set up continuous integration in order to prove that your product works. Exactly what I just said. Proof. That's the key word here. You prove it to me. You're guilty by default. You're not innocent. So I don't trust you by the definition. I don't love you by definition. I don't respect your work by definition. You're a total stranger to me. I just go to your repository. You have a few seconds of my time. And if in these 2 seconds, a few seconds, you catch my attention and you show me that, look, this stuff is buildable, it is a product, then you have me with you, maybe. But if you don't show me that, that's it. How do you show? You create in GitHub, you use GitHub Actions, that's what we use right now. You use GitHub Actions to automate the build, and you put a badge, a nice looking badge on your page, on your README file, which shows that it is clickable. I can go there and I will find the logs, I will find the protocol of how you put pieces together. So you're like, I'm saying that you have to do that you owe me that. You must do that. If you don't do that, don't blame me for walking away from your repository. Let's see what people are saying about that. This paper, quite old. It's actually about 10 years old when GitHub was, GitHub is actually, it's 16 years old right now. So that page was like when GitHub was 6 years old. Not so, well, it was popular at that time already, but not as it is now, because now it's totally dominating the market. So they did an analysis and they showed that the teams who actually use CI, well, it's like I said, it's not anymore a CI, it's more than CI right now. It's about integrating, it's about checking the quality, it's about automatically sometimes creating issues, automatically creating pull requests. It's not continuous integration anymore, right? Because continuous integration was quite niche and, well, quite narrow concept. Just like I said, putting the pieces together, building and raising the flag. That's all. That's the continuous integration. But then we got continuous delivery. So you can integrate and then you can deploy it somewhere. You can create a new release. You can put your binary product to some platform. So that was continuous delivery. And then we got into way more features of this automated actions, as they are called on GitHub. You can, like I said, for example, create new pull requests automatically. So your GitHub action will just check your code, look at something which is important, and then create a new pull request because certain changes are required right now. So for example, I use it for automatically increasing the version inside the README file. Inside the README file, I have in some places the information about the current version of the software. And then I have a GitHub action, which automatically goes to the place where I deploy my versions. I make releases to, for example, to Maven Central. They check what is the latest version, and then the script, it goes back to the README file, makes the changes there, and then because it cannot push to the repository, I didn't give the permissions to the script. So the script creates a pull request, and then I merge the pull request. So it acts like a programmer, like a fellow programmer with me. It just does what I don't do manually. The script does more effectively. Look at the summary of that paper. They are saying that the teams who use continuous integration are significantly more effective at merging pull requests. So they merge faster, they merge more. The pull requests submitted by core members. Core members are the people who, well, I don't know exactly the definition they make in this paper, just don't remember, but you can understand that the core members are people who contribute most frequently, let's put it this way. And then there are external contributors who are coming to the team from the world, and they have fewer pull requests rejected. I think it's connected to the fact that these people, external contributors, they just understand better what is expected in the repository because they have the CI, they have the automated response from certain scripts which just tell them what's good and what's bad. And if we have these scripts, if you create such GitHub Actions, which will automatically inform me when I submit the pull request, what's good, what's bad there, what will happen when the merge will start will start to attempt the merge process or the merge bot, or maybe the person who will do the merging. I understand what kind of problems they will face, so I can fix them before I ask you to try to merge my request and then reject it if something is wrong. So you are making a big favor to your contributors if you automate the process of integration. If you don't, then you kind of keep me in the dark about your expectations of what needs to be done, how the tests must be working, and all that. And if I look at the repository and then I clone this repository to me, let's say I love your repository for some reason, even though I see that there is no continuous integration, well, in my case, I'm not going to love this repository. But let's say there are people who may love you in this case, may enjoy making an attempt to work with your repository. So they will clone it to their computer, and then they don't know how to check whether their changes are good or not good for your repository. They may only guess. They may try to make some changes, send the pull request, and then wait. What happens? We don't know. Maybe they will accept the pull request, but maybe not. So do I want to take that chance? Do I want to gamble like that, wasting my time on a repository without an integration script? Most probably not. So it's not about rejecting people's code, because you will actually reject, because if you automate, then there will be more reasons for rejection. If you don't automate, then the only reason for rejection is going to be your personal opinion. I submit code to you, you say it's not a good code. Why? Well, because you think so. It's your repository. I'm not going to argue, but that's it for me. That's the only opinion coming from you. If I convince you, you get the code. If there's a guy who is sitting next to you and this guy is a robot, then there will be two opinions. Your opinion plus the opinion of the robot. So I need to convince two people now. And convincing the robot may be even more difficult because it's a robot. So yes, it will be harder for me to integrate, harder to get my pull request merged in, but it's going to be a more predictable process. More predictable. Predictability will help people to get on board with you. Predictability. Keep it in mind. Let's look at some papers which are way more recent. Oops. I don't know what happened. Some of them are way more recent. And this one is about how often people use continuous integration, how often they use GitHub. Well, there's not only about GitHub Actions, they're talking in general about continuous integration. So how often open source, and they're looking at Android apps. So they're looking at Android repositories, and there are a decent amount of them, 84,000 open source repositories from 3 different sources, GitHub, GitLab, and Bitbucket. So I believe these two are kind of less popular right now. I don't want to cross them completely, but you must understand that if you keep your code in there or you keep it there, then most probably you have not so many chances for being popular as comparing to GitHub. Fortunately or unfortunately, that's a separate discussion. Like, is it good that we have so much dominating platform in the market right now where all of the projects, or the majority, the vast majority of the projects are being hosted at? Is it good or is it bad? That's a separate discussion, which is also interesting to have, because I do believe that it's not good. But I don't see an alternative. I don't see a solution. I cannot imagine a second platform to coexist with GitHub. because it's going to be not good for the environment, I believe. Because we will have to maintain two profiles. For example, me, I'm a programmer as well, so I write code on GitHub, and I will need to maintain my profile there and maybe there. And how do I get used to different interfaces? How do I switch? So it's not really comfortable. It wouldn't be comfortable. It's like having different operating systems. It's already a mess. Like we have Windows and we have Mac OS and we have Linux, so it's hard for people to work together because of these differences. So if we have different platforms, it's also going to be, I think, it's not going to be good. At least this is what I see now. Maybe my opinion will change if I see something really maybe compatible with GitHub, so that they can integrate somehow, so I can switch to the platform freely without the necessity to move my profile from one place to another. At the moment, it's hard to imagine. It's like Stack Overflow. It's yet another monopoly. It's yet another central place of the knowledge and internet. Like everything we know now about programming, about solving programming problems, they are in Stack Overflow. And if you create something different than Stack Overflow, I'm not going to sign up there. I'm not going to be there because it's going to be a distraction for me. It will mean for me to move my energy from the place where I keep my knowledge to a different place. And if you have many places like that, like we had before, like we had 15 years ago, we had multiple GitHubs, not GitHubs, but other platforms, but there were many of them. There were many places for knowledge sharing, like Stack Overflow, but there were many forums. A forum for Java developer, a forum for PHP developer, a forum for JavaScript developers, multiple places. That was a mess. So now we finally have a central place, which is at the same time, it's not good because everything is in the hands of one company. So that's a problem. Okay, sorry for this sidetrack note. So let's see what they found out. They found out that only about 10% of the applications, they use CI/CD services. The majority of open source Android apps are developed without accessing CI/CD. Well, this situation is not uniform for all programming languages or all platforms. So I believe if they would check not Android apps, but for example, Java frameworks or Java libraries, and they take, instead of 84,000 open source repositories, they take 10,000 of the most popular repositories on GitHub, then definitely it's not going to be 10%. It's going to be way more. But on average, because Android apps, they're not frameworks, they're not libraries, they're not something which people are supposed to share with other people. So basically, the developers of Android apps, they're less interested in external contribution than developers of Java frameworks. And that's why I think, that's my interpretation, and that's why such a small percent of programmers actually care about integrating, which is kind of a proof of my previous point from which we started from, that you do the integration these days, mostly not for yourself, if we're talking about open source projects, but mostly for outside users and potential contributors. You show them that you're good for them. So these people, they don't care, these Android apps developers. So that's why. Let's see one more interesting study. Now they're saying about the rise of the GitHub Actions. This is GHA, stands for GitHub Actions. So GitHub Actions showed up, you see if the paper is 2024 and that's 18 months, so they showed up as approximately, I believe, maybe 19, something like that. So that was about 4 years ago. So 4 years ago, instead of Travis, which we're using for another 4 years before, GitHub introduced GitHub Actions. And Travis got, I believe, out of the market. And there were many more systems at that time. There were I was even the developer of one of them. I had a hosted service for GitHub integration. And I think many people did that. So many people believe that this is an interesting market because it looked like an easy product to build, reasonably easy, and it looked like something which any programmer would need. And GitHub didn't have it. So there was a gap in the the blank in the gap in the market, how to say. So it was an obvious demand of the market, but there was no supply of GitHub. And that's why systems like that, they existed. And then eventually GitHub introduced their own platform, and now we all use it. And look at what happened when GitHub created that. So look, there are systems which you can see there are names of them. So each line of a different color, it's a system, and then the amount of repositories which are being hosted by these systems. And it's definitely not the total number, because definitely the total number is not like 40,000 for GitHub Actions. It's more close to maybe 40 million or something like that. So there are different order of magnitude, but this is the number of repositories these guys were analyzing. So as far as I understand, they were tracking a number of repositories, and they were watching what kind of CI service this entire set of repositories are using. That's how I understand this research method. So you see, this is GitHub Actions. That's quite interesting trajectory, right? So they just started and they immediately covered the entire market. So now I believe if you continue, because this is 2021 or 22, so now we have 24. So I think the trajectory is like this, and these guys are going in this direction. So now we have a total dominance, the total monopoly of one specific service. Does it tell you that you need to go to use another service in form of a protest? Definitely not. You stay with GitHub Actions. This is the most advanced platform right now, and they have everything you need to have. For other platforms, we just can feel sorry for them because they definitely lost the market. I was an active user of all of them. I checked Azure, I definitely was using Travis for many years. I used CircleCI, AppWeaver was amazing because that was the only platform which provided the ability to build on Windows platform. Because all of these systems, well, Jenkins it's a hosted system. It's not a cloud service, but all other platforms, they didn't provide, like Travis, for example. Travis didn't have an ability to build my code on Windows. There was only Linux and not even Mac OS. And when GitHub showed up, GitHub Actions, now GitHub Actions, they provide Mac OS, they provide Windows, and they provide Linux, Ubuntu. So GitHub Actions is definitely the leader. Now let's continue with more recommendations. Recommendation number 2, I suggest you to try to, as much as possible, to use fixed versions in your build system. I mean the versions of dependencies. So let's say you develop a JavaScript library, JavaScript framework. Then you definitely need other frameworks or other libraries to be your dependencies. And in your package.json file, you will specify the versions of them. And there are 2 approaches to that. The first one is to specify a version like this. For example, I'm okay with the version 0.5. This is one way to specify the version you're looking for. Or maybe you can say, I'm okay with the version which is more than equal to 0.6. That means that 0.63 is okay for you. 0.73 is also okay for you. Version 1.2.7 is also okay for you. This is what this message is saying. And if this is what you do, then when I check out your repository, when I clone your repository, then the chance of not building it and getting a failure is very high. Because when I clone it and I run the build, then I'm going to use the latest versions, which in this case may be this one, for example, 1.2.7, which is too high, which may not be suitable for your code because of the changes this version introduces. It's, again, a very broad discussion, very large topic about this, how to manage dependencies. But my quick recommendation is just, as much as possible, use fixed versions. This is an open source community, will increase your chances for getting the chances for attracting developers, because they will be able to build your stuff locally. There are some limitations coming with that, because if that would be a recommendation for all and a generic recommendation, then people wouldn't have non-fixed versions. They would only have fixed versions. But we do have versions like this because we need it sometimes. But that's sometimes. In general, we don't. In general, it's better to have fixed versions. Again, maybe I'm not really right when I'm saying in general, but in case of open source, let's put it this way. When you develop a framework, when you develop a library, then definitely having fixed versions is a recipe for failure, because the users will not be able to use your library in any particular situation they might think about. You make your library very rigid, very definitive, very determined for the use cases. And that's hard to use your library if this is the case. So people use flexible versions like that or that in order to let their users be flexible. But if this is the case for you, then when you configure the testing setup for your library, then in the tests, you specify the fixed versions which are substituted for these templates, for these predicates. And this is usually done with the help of these so-called log files. So if you have package.json, then you have package.log or something, where these specific versions are fixed, and then the programmer just clones your repository together with the log file, and the programmer knows what's the perfect configuration for testing your code. And the programmer will use it. The programmer will not update the log file, because that will most probably lead to failures. So let me extend these recommendations. So keep your log file, which is used for, I think, for Ruby, for Python, I believe, for JavaScript, not for Java, but for many languages. For Rust, for example, they have this log file, which is the information for the user of what's the perfect configuration to run during testing. So keep this file together with your code. That will help your customers. Next recommendation, use build metrics. If you don't know what it is, I'll show you. But in general, it means that your integration happens on a number of platforms, on a number of virtual machines, on a number of operating systems. And why it's called matrix? Because you want to define it like a matrix, maybe like a cube or multi-dimensional, but still we could call it a matrix, but multi-dimensional matrix. Let's say you have operating systems. You say, I want my code to be tested on Mac OS, I want it to be tested on Windows, and I want it to be tested on Ubuntu. And then I want this code to be tested on Java 11 and on Java 17. And that's it. So this is your matrix. And you configure that matrix to GitHub Actions, and the GitHub Actions will run your script, your integration script, your build 6 times. 1, 2, 3, 4, 5, 6. 6 separate executions of your build. So let's say you have a C code, Python. You have a Python script which makes a simple calculation of this and that. So you want to check whether this Python script actually calculates what it's supposed to calculate. You provide some number to it, and it prints you back another number. A very simple script. You run it on your local computer, and it works for you. But you don't know what kind of computer the user will have. So you want it to run on Windows, for example, because you don't have Windows, you have Mac, and you want to know what happens when a user with Windows will run it. So that's why you create a matrix, you create a setup for GitHub Actions so that they run your code on on Windows. And then the question is, what kind of Python version is going to be there, or Java version? Also, the user may have different versions there, and you want to make sure that your script doesn't break on Python 2. It not only works on Python 3, it also works on Python 2. So you want to be sure that that's the case. So, and that means that there will be 6 different containers started, or 6 different machines, let's put it this way. 6 different servers will be created by GitHub Actions in order to test your script. You can create even more. You can say, okay, this is Java version, this is Java version. How about we make it in 3 dimensions? So Java versions, and okay, let's split it this way. So we have, I'll try to write something. So that's Java 11, this is Java 17, and then we have Python. So I want to also test on Python 2 and Python 3, because my application is using Java and Python at the same time. That's why I want in my build setup to check how it works on Mac OS, on Java 17, and on Python 3. And then I want to, this is Python 2. This is Python 2. This is Python 2. And then I want Java 11 and Java 17, and I want Python 3, and I want Python 3. So that's 3-dimensional matrix now. So we have build number 7, 8, 9, 10, 11, and 12. That's how many builds GitHub Actions will do for you every time you make a push. Every time you put something into the repository, GitHub Actions will start 12 different servers for you at the same time and run your build on all possible different combination of environment software. And this is what you're going to see, and this is how you configure it. First, let me show you how you configure it. This is a very simple configuration I took from one of my, no, it's not my project, sorry, it's the documentation coming from GitHub. So they say it's called matrix strategy. You see what they do. So you call it matrix, and then this is strategy, this is matrix. So you define operating systems, you list them, operating system 1, operating system 2, and then the versions of something, 1, 2, 3. So all these configuration that you use, this is actually YAML, as you might know. So this is YAML for GitHub Actions. So all this strategy means is that the GitHub Actions looking at this tag, at this element of the YAML called strategy, will just understand how many servers need to be allocated for each scenario, for each build not the process, but the build session. Let's call it session. Every time you push, the GitHub action triggers the session, and within this session, they understand, okay, we need 2 multiplied 3, 6 machines. And then they give you these 6 machines, and in each machine, they give you different values of the OS and version. And look what happens. You say runs on, and here you use the variable matrix.os. So the value will be different. On one machine, it's going to be Ubuntu 22. On another machine, it's going to be Ubuntu 20. And then the matrix version goes in here. So when this setup node plugin will run, it will use a different version of the Node.js. So that's it. And when you, I wanted to show you the output. Yeah, let's scroll up a little bit. So this is how we use it in one of my projects, and that's what the output looks like. So you see that's a green sign, meaning that the build was successful. It's that Maven project, so it runs well on Ubuntu this version, Ubuntu that version, Windows, and Mac OS. So there are 3 operating systems and 2 versions of Java. So in total, that's 6 different builds. So it's very good practice to do it this way. If you don't use build metrics, you're kind of underusing GitHub Actions. You're not using them to the full extent. They recommend you to do that. They're saying a metric strategy, well, they're not saying in this particular quote, they're not saying it's good, but believe me, it is good. It's something that will strongly contribute to the quality of your product, because it will test the product from different angles. And I cannot even count how many times I saw problems after my code is clean, after I build it on my local computer, after I push it there, and even after I release it to some repository, and I'm so happy that the product is done. And then I create the matrix, and in the matrix I say, let's use Windows, or let's use Java 21. And after that, I see that there are still things to be improved, because it doesn't work on Windows. That's the most popular case, in my case, because Java, Windows, they're not really good friends. And that's why every time you introduce Windows, you see problems with encoding, you see problems with the line endings, you see different kinds of problems. But you have to see those problems. You have to go through them in order to, again, to prove to your users that the product is worth paying attention to, that you deserve my attention. You tested it on 3 different operating systems. Definitely, I'm going to pay attention to what it is. But if you barely tested it, meaning that you tested on 1 operating system and 1 version of Node.js, that means you barely tested it. That means you didn't pay enough attention to this product. So then I'm not gonna pay attention either. Yeah, that's an interesting quote relevant to that. They are saying that the use of multiple integration environments, and that's exactly what we're talking about, that's matrix environments, leads to 10% more failures at build time. That's what exactly I told you right now about Windows, but they have the numbers. 10% more failures at build time, and that's good. The failures in build time, they are very effective failures. These are the failures we're looking for. We want those failures to be with us. We want at build time something to fail. If nothing fails in build time for a long time, then we're not doing the proper organization of our development process. Build time is the right time for failures. So don't take this analysis negatively. It's good that we fail because of multiple build environments. So use the metrics. GitHub will allow you, at least for now, GitHub is, well, Microsoft is paying for that resources, and they allow us to use for free to use their servers for our builds, and they give a lot of build time. Well, I have multiple repositories, and in all of them, in most of them, I use GitHub Actions, and GitHub, well, is not charging me anything. Well, I do give my credit card to them because sometimes it happens. Sometimes by the end of the month, they send an email to me saying that I overused their server time, and I spent, well, these jobs, which are the GitHub Actions jobs, they take more time than I'm allowed to take. But that's reasonably low over, like I pay, I don't know, a few dollars a month. It's not a lot, just a little bit. So the platform is very generous right now, so far. Use it. Make these matrix environments, well, to some extent, of course. So definitely you need to use 3 operating systems, but using different versions of them, like Ubuntu 22, Ubuntu 20, Windows 2022, Windows 2021, I would not recommend to go that far. I think it's enough to have Mac OS, to have Windows, to have Ubuntu, unless you develop something system level. Unless you develop a library, a C library, for example, which communicates with the operating system, and it's very important for you to guarantee that you communicate well with different versions of them. Then yes, you go for that. But in normal programming, in a high-level programming, we care about different versions of Java, of Python, of Ruby, of Java, of Node.js. That's what we care about. Next recommendation is to provide Dockerfile. When you give me the repository, and in this repository you have a collection of files, and then you have some automation, so you have some scripts which I can run locally and make sure that everything works in your repository, and I can see that on continuous integration or on GitHub Action side, this script also works. It makes me happy. But I do understand that it may be hard for me, especially in case your software is complicated, to reproduce the exact environment you have in your GitHub Actions. Let's say you have many things to be installed. Like say you need to have Java of specific version, you need to have Python of that version, you need to have Python dependencies, you need to have some Java dependencies, you need certain things to be installed. And I look at your GitHub Actions configuration and I see that you install many things there. I don't have those things on my computer and I'm not so interested to install them. For example, I have Java 21 on my computer, but I see that on GitHub Actions you installed Java 11. So what does it tell me? It tells me that I will have to do it locally in order to make sure your scripts, your code works. I don't want to do that. And not so many people will actually enjoy installing something in order to make your code work. So now in 2024, we have Docker. And it's a good practice for a repository to provide a Dockerfile, which I can run and build an image locally, a Docker image, and then execute your code, execute your scripts or whatever you have inside this Docker image. So I can give an example, a practical example of the one repository which I have and in which I have such a complicated case of configuration. So there are many things that need to be configured before you can actually run the tests. So what do I say on the README file? I say in the how to contribute section of the README file, I'm saying that you need to run the entire suite doing this. So first you need to do make install and pay attention, you have to do it with a sudo. So I'm asking my users to take a risk on their computers, to take a risk of damaging something. Because running the code with sudo means putting the risk, their computers at some sort of risk, because they don't know me, they don't know what's going on in this install script. So I'm asking you to do that anyway. And then after that, I'm saying after that, you will be able to run the build. And then I'm saying, okay, and then if everything works well, then send the pull request to me. But that's kind of not friendly, I would put it this way, to the user. Because, like I just said, not so many people are going to enjoy it. Because of that, I say you can also test with Docker. So all you do first, you just build an image locally, which will include all the necessary setup, all the necessary elements which I expect to be present in order to run the tests. And after that, you just run Docker run this image which you just built, and then inside the image you will do make test. So that's exactly the same command, make test, or that's a typo. It's better to say lint here as well. So it's the same command, make test lint, the same as here, but inside the container. And that's a way more friendly approach, way more friendly, way more attractive for newcomers. So I encourage you to do the same. I encourage you to provide a Dockerfile so that a newcomer, a potential contributor, is not going to do that. He's not going to install anything, but only use the file you already have. I see you're asking, do we need Dockerfile for Android repository, for Android app repositories? And what for? That would be exactly the same case. Imagine I'm the developer for your Android app, and I just join your project, I just join your repository, and you expect me to help you. So I will need to install something locally, right? Well, I know that you guys in Android development, you don't use integration from the command line that much. You use these IDEs, which just, you click one button and some magic happens, and then you get an APK file, and then you just deploy it somewhere, and then the code works. But that's not how professional developers are supposed to work. We are supposed to always work, when we build, we always use command line. We don't use IDE. So IDE is not the way to build stuff. IDE is to edit the code, but not to build it. Maybe IDE is okay for running individual tests because it's faster. So you just move your mouse to the location in the file, in the test file, then you click one button and one particular test just runs. That's okay, that I can understand. But you will always need to have for your project one script which is executable from the command line, which I run, and it builds all together. That's what you need to have. If you don't have that, you should start reconsidering your software engineering practices. But I know, like I said, I know that Android developers are not that advanced. So the majority of them just use IDE, they just put pieces together, click build, and then click deploy, and then they open the phone and they see how it works. I feel sorry for that, because I tried that myself. I tried to develop Android apps a few years ago. I remember that I even found a very professional Android developer and asked him to assist me in setting up the build so that I can run it from the command line as a single script. And we spent like 2 hours talking to him and discussing and configuring that stuff, because he was puzzled. He was together with me solving certain problems, and we together set up this system. So it's really not really typical type of activity which Android developers do these days. That was 2 years ago. Maybe now something is different happening. But to my knowledge, CI is not the favorite practice for Android developers. And we actually had a quote here, remember? They said that that's just 10% of people who use continuous integration on Android world. So maybe the situation now is the same. People just don't integrate from the command line. They just use IDE for that, which is wrong. in my understanding. So making a Dockerfile, make your users happy with that. Next recommendation, be aware of Flaky tests. By being aware, I mean you need to understand what they are, these Flaky tests, and you need to be prepared to fight with them. The Flaky tests is the number one, the primary source of troubles for continuous integration. This is why people don't like continuous integration. This is why people don't like testing. This is what people usually provide as a counter argument when you try to convince them that they should automate testing. They say it's not possible because if we test it, it may fail sometimes because of the blah, blah, blah. People don't know how to write tests well. They write Flaky tests. Flaky tests are the tests which fail sometimes. You run it once, it works. You run it twice, it doesn't. For example, a very simple Flaky test. A equals to random, which is, let's say, from 1 to 0, including 0 and including 1, for example. And then you say assert, you make a test. Assert A is always less than 1. So you make a mistake. Instead of saying this, you're saying A is less than 1. You understand that if I run this test 1,000 times, it's going to pass. If I run it 1,000,000 times, it's going to fail. At least once or something. I cannot guarantee you that, of course, but you understand what's happening. You understand that this test is not stable, is not 100% stable. It may fail. And it's going to be a question for people if they see that code, because it just successfully passed a second ago, a day ago, a month ago. So everything was good with this test for years, and then suddenly now it breaks. This is called Flaky test. And people are very good, we programmers are very good at writing that kind of tests. That's a simple example, but there are way more complex examples that exist, and we need to be aware of that. And it's better, in my opinion, it's better to have smaller amount of tests, less tests, than having Flaky tests. So that's a quote. They say that, and what the Flaky tests lead to? They lead to restarts. They lead to instability of your builds. You have the build, which is successful today. You start it tomorrow, it's not successful. What do you do if it's just a Flaky test? You just rerun it. You push something to the repository and boom, your GitHub actions are green again. They were red, now they're green. So the study says that developers restart almost 2% of tests. Restart because of the failures which were caused by Flaky tests. So they just restart. They don't change anything. They don't improve the tests. They just restart and see that now everything is good. Of course, it's frustrating for the developers. And if your contributors, if the people who will come to you in the open source, they will see that your your build is not stable, that you rerun it, and sometimes it's green, sometimes it's red, sometimes it's green, sometimes it's red. It's an indicator for them that the quality of your repository is low. And of course, they may reconsider their decision to join you because of that. They're saying here that the restarted builds are mostly the builds that are initially failing due to a test network problem or limitations. That's also a very interesting reason for a Flaky test. Limitations. And pay attention, the paper is 4 years old and they're talking about Travis CI. That's when GitHub Actions didn't exist or they were not popular. They're talking about limitations. That means that, for example, you run the test and in your matrix configuration, let's say you, limitations. Limitations means, for example, time limitation. When you run a build on GitHub Actions, you will not be able to run, if I'm not mistaken, for more than 60 minutes. But I may be wrong. Maybe it's possible to run for longer. But there are certain limitations. for the duration of the build. So if the build takes longer, then they just cancel it. They, on their side, on the GitHub server, they just stop it and call it red. So they say it's a failure. Even though there was not a failure, it was just a test which occasionally takes longer than allowed to take. That's an example of a situation where the test is flaky and it's not good for your stability. So now I'm just giving you just a taste of what's happening. It's a subject for another course of the Flaky tests, because there are a lot of things to learn. Now just understand that it's better to have less tests than tests that are not stable. This is how you will discourage your contributors if your tests are flaky. Another interesting suggestion, in my opinion, is to use one of these two very good, as I know them for many years, bots on GitHub. One is called Renovate, which we use now more actively, and this one which I was using in the past, Dependabot. What they do is they look at your repository, and when they see that there are some dependencies, like dependencies, I mean the packages, the frameworks which your code depend on. For example, you develop a JavaScript product which depends on certain JavaScript dependencies. They see that you depend on version 0.1.7, and they understand that now they have a new version, 0.8. So what they do, they just submit a pull request to you, suggesting to upgrade the version from 0.17 to 0.18. What is not good is that they are not trying to build your product. They're just suggesting a pull request. So some of the pull requests which they are suggesting, they're not gonna pass because they will break something. Sometimes you cannot just increase the version. You need to also change the code. And this is what these guys are, to my knowledge, now they're not doing. So they're not trying to build your code, they're just making a very simple syntactic a textual replacement of the number, and then see what happens. So be careful, don't just accept their pull requests blindly, but definitely use them, because they will keep your repository up to date. They will try to constantly refresh your repository, which is a good indicator for the people who watch your repository. They will see that you are looking for changes. You are interested to grow your repository together with the dependencies. The dependencies grow and you grow. You don't want to stay put. You don't want to stay where you were 2 years ago. You want to upgrade, because I think it should be obvious why we want it this way, because we want our code to be compatible with new versions of the libraries and frameworks which we depend on. And these two guys, two robots, they will help you with that. That's for sure. Use them. It's easy. You just configure them in one click of a button. Just find them on GitHub, click the button, configure. You don't even need to change anything. No code. You don't need to write a line of code. It's just a click of a button. You accept, you give them access, and then they start watching you. And they are free, which is also nice. This one is made by GitHub, so they're just providing this service, and this one is made by somebody else. It's not, to my knowledge, they're not associated with GitHub anyhow. It's external service, which is also free. So they are paying their own money, they're investing their own resources into helping us, open source programmers, keep our code in shape. Isn't it great? Another recommendation is to discriminate or separate or clearly understand the difference between fast tests and slow tests. Some people understand the distinction as unit tests and integration tests, but a more fresh, a more modern understanding is that there are tests which are fast and there are tests which are slow. We want them both to be in the repository. We want the slow tests and we want fast. What's the key difference? The slow tests, they're way more they are way more important for the entire quality of the software. But fast tests are way more important for the simplicity of making changes to the repository. Slow tests, they protect the repository against damage. Fast tests, they help the developers to make those changes faster. When I'm a developer, I clone your repository, I look at all the tests you have. I don't want to run all of them because they are both fast and slow. They will take a lot of time. But I want to make some changes in the code and then quickly, preferably in a few seconds, to see whether my changes are breaking something. And if something is broken, then I revert my changes or modify them and I run the tests again. And I want to use fast tests for that. I want to run it again and again multiple times a minute, many times a minute, while I make changes to the code. And then when everything is finished, when I'm happy with the fast tests, I see that they work, and then I put everything together, send the pull request to you, and then watch what happens. Your servers, they start multiple servers because you have the matrix environment, so you run it for half an hour, and then you let me know whether everything was okay. And if it's not okay, then I start making changes again running my fast tests, and again I bring my code to you, and then again your server starts running the slow tests. The majority of programmers, they will not run slow tests on their computers because it's time consuming, it's boring. Not so many people are going to do that. But we need slow tests because they are mostly integration tests. So they create more complex and more sophisticated testing scenarios. They do many things which fast tests don't do. So you have to discriminate them, you have to separate them, and that's how you're going to help your users, your contributors, to be faster, to join you faster. If you don't make such a separation and all of your tests are in one group, then it means for me, then let's say the slow tests, they run for 15 minutes. And the fast test, they run for 15 seconds. That's how it should be. Well, it should be 3 seconds altogether. Let's say you have 100 tests, and then you have 100 tests. So these 100 tests, they run for 3 seconds, and these 100 tests, they run for 15 seconds. So in total, you have 200 tests. If I clone your repository and I have 200 tests which run for 15 minutes plus 3 seconds, and it's annoying. I don't want to run that. I don't want to wait for 15 minutes every time I change something. I want to wait for 3 seconds. Make this separation clear, obvious. So make an instruction, explain it in the README file, how I can run these guys without touching these ones. Because this one is for the server, and this one is for the user. So people use these tests, and computers use these tests. You can read more in this blog post, which I wrote just last year, I believe. Okay, and 2 more recommendations and we're done. Caching. In GitHub Actions, it's very important. GitHub Actions provide you the mechanism to make their execution faster. We don't want them to be longer, but you must understand that when the GitHub Action starts a new server, it's a clean server. So it doesn't have many dependencies which are required for your product. For example, there is no Java there. There is no Python there. There is no Node.js there. So you need to install all of that in order to start using the server. And you can imagine how long it may take to install Java on a clean Linux server. It may take a minute or so, maybe even longer. We don't want that to spend on every session, on every push. That's why people introduced so-called caching. It works this way. There is a storage. GitHub provides it. GitHub provides a storage where the GitHub action, when it starts, it can look into this storage and download from there something already prepared. For example, the full installation, not installation package, but the fully installed archive with Java binaries and everything. And I'm not going to go into details how to configure it in everywhere, but just remember that this is important. So if you see that your GitHub action is running for longer than a minute, then most probably you're doing something wrong, unless this time is spent on your tests. So of course, if your tests are very slow and you need to run them for 15 minutes, then it's okay. But usually the tests, what happens is that people have quite short tests, but the setup is very long. So they pre-configure these GitHub Action servers for quite a long time. And it is solvable through caching mechanism. Just read it on your own, understand how it works, and just use it. And let's see what the study says. It's actually this year's study, very, very fresh. They say that the majority of the resources is consumed by testing and building. And they say that caching is adopted only by 1/3 of repositories. They overall remain underutilized. So they conclude that caching is not being used well, just like exactly what I said just now. That the majority of people just have a problem with that. They set up the server in the GitHub action for a long time, for a few minutes, and then the tests take half a minute, which I'm also not good at it. So it's not technically easy task to do, to configure this caching, but it is doable. Learn how to do it, and do remember that that's important, the caching. Okay, and the final recommendation, that it's good for you to understand that it's possible to create your own GitHub Actions. GitHub, they call GitHub Actions. So you can create your own actions, which may be used by other people. If you see that you're doing something useful for your project, like setting something up or pre-configuring something, then you may share that with other people. GitHub allows you to do that. However, it's difficult. That's why I'm showing you this study, actually of last year. They're saying that developers find it challenging and error-prone. It is difficult. I mean, it is for now, because it's quite fresh activity and quite young. We have it just for a few years, so it still remains something that is more complex than expected. When you start making your own GitHub action, you need to do it at least once in order to understand the pitfalls, in order to understand the mechanics of this, how it works. But when you understand, you will find out it's not a rocket science. It's not a rocket science. It's something that it is possible to do. I did maybe 4 or 5 GitHub actions over the last few years. And I, in the end, I believe I learned the mechanism. But of course, I'm far from being professional in that. But it is something that I encourage you to try to do. When you see that something is possible to automate and may be used in a number of repositories, not in a single one where you need this automation, but in other repositories as well, create your own GitHub action and let people use it in their repositories. And let me show you something funny. So look, this is the article written in 2023, so about like 1 year ago. And they're saying there are over 15,000 actions in existence. I quote. And they say they're being published every day, blah, blah, blah. Now, if I check the amount of actions there, it's 23,000 and a half. 23 and a half. while it was 15 in 2023. Now we have 2024. You can see that the people keep publishing. People keep making these GitHub Actions, which are the instruments of automation. I think this stuff is the core element, the core ingredient of software engineering best practices in the world right now. It's not about programming. It's not about how to write Java code. No, it's about how you organize your development practices, how you check your code, how you test it, how you integrate, how your release cycle is organized. So everything about software engineering is in this place right now. In the market, they call it marketplace on GitHub. That's where the knowledge is. I recommend you to go there time to time and look at the top most popular elements. You will see how people these days understand software engineering, how they automate their work, and try to use their actions. Try to borrow this knowledge. Try to learn from them. It's like learning from static analyzers and style checkers. But static analyzers and style checkers, they are about writing code. This stuff is about automating, is about organizing the work around the code. That's what I strongly encourage you to do. And that's also interesting, my final slide for today. Look, they are the previous paper. They ask people, they ask programmers why they create actions. So why they contribute to that. And they're saying the first category is there's no existing action available, which is reasonable. Then existing actions are limited in functionality. Existing actions are not performant. Not sure how to find reuse actions. Existing actions too complex. So these are the reasons why people go there and why they create. I encourage you to be in this category, of course, if you see that there is no existing action and you have some interesting idea in mind, how to improve the work you do, how to automate something, then that's the way to go, to contribute to that marketplace. That's how you make the world better, and this is the place where you learn from other people who already tried to make the world better. So that's it about integration, about GitHub Actions. Like I said, this is the primary place right now. Get there. See what people are doing there. I enjoy reading this marketplace a lot. I just don't have time to use all of this interesting stuff in all my repositories because this integration takes time. So you need to get this action from there, understand the configuration, put it into your repository, see how it works, and start enjoying it. And then the next one. But if I would have, unlimited amount of time, I would take hundreds of these actions from this marketplace because there are many interesting bits there, many interesting robots and scripts that automate software engineering. Try it out, you will see for yourself. That's it. Thank you very much. See you next time. Bye-bye.